Now, apart from layers, there is something which is called as activation function. Okay, so activation function. Now you can again imagine, as soon as you touch the hot plate, or you touch some surface where something was very sharp, and immediately you removed your hand. So what exactly happened at that point of time? What happened? So at that point of time, if you see that the cells got activated, okay, there was immediate activation in the cells. So that kind of activation, if you see, it happens with the help of activation functions. Okay, it happens with the help of activation functions. That kind of activation. Now, in case of the artificial neural network, what activation function can do? So activation function, they can do the product of each individual input value and the weight of the channel it has passed over its so what it can do is the product of each input value and the weight of the channel it has passed over is found. Okay, so this also I'll give you some example and tell you. So it computes the sum of the weighted products, and we call this as weighted sum. It adds a bias unique to the neuron, and when we then subject the final sum to a particular function. Okay, so by reading it might not be very clear, so I will tell you how does this happen, okay, in a simple manner. Here I'll show you in Excel. Okay, so what we will do is we will have some input needs to be there. Okay, now input could be, let's say here we have input as mm, hours. So here what we will have, let's say we have 2 hours, we have 4 hours, we have 1 hour, we have 3 hours. This way we have hours. And let's say number of books we have 7, then 8, then 4, then 9, this way. And then score we have something. So this is sample data which we have. Okay, a small sample data I have created. We have hours, books, and scores. Okay, and simply I have computed score as hours into books. That is how I have computed the score. Now, if a neural network has to work, how does it work? The product of each input value and the weight of the channel it has passed over is found. Okay, so what is going to happen here? Now we need to see that what is input and what is output, right? So here we need to see that what is input and what is output over here, that we need to understand. Yes, so now what will happen? Here we need to identify that what is input and what is output. So this I will take as input. Okay, these two columns I'll take them as input, and this score is output. So this one we will take it as output. Okay, so now we are clear on input output pairs, right? And we have x1 and x2, like two inputs and one output we have. So what I'll do is let me just, yeah. So how do we need to identify uh, like fit this into a neural network? So there's an equation in neural network. There's an equation, and that equation is that if you want to identify the output, okay, or I can say y. So how y will get identified? Y is equal to, so here we have x1 and x2. So we have x1, and x1 needs to be multiplied by some weight, and we call it as w1. Okay, then we will add it. Okay, plus then we have x2. X2 also needs to get multiplied to some weight, that is w2. So x1 will have some weightage and x2 will have some weightage. They will get multiplied to the weightage, and then we will find the summation to it. Okay, and then there will be um, one term which we will name it as w naught. Okay, so normally that term we name it as w naught. So normally what you can do is you can put it at the beginning, है ना? So you can put it at the beginning, that is called as bias. So let me get it there. So here you can have w naught. So w naught plus this way. Okay, so this is how it would be. This is the formula. Fine. So y is equal to W naught. So what is W naught here? That is the bias term. Okay, we can write it as B also. At many places, we simply write it as XW plus B. Okay, and then if we have multiple X, so it increases X1 W1, X2 W2. This is how we write. So B or W naught is equal to, so B or W naught is equal to what? B or W naught is your bias term, and then W1 and W2, they are weights. Right? This is how it happens. Now in this case, if I want to know y, so y will be equal to, yes, equal to what? We don't know what is the weight for hours, so it will be 2 into W1 plus 7 into W2, and then what we should do, and then plus we will have the next thing as W naught. Now you can see, okay, I just need to remove this is equal to as of now. This is what is there, right? This is what is there. Let me take some simple example. I'm sorry. Let me take some very simple example. Now, uh, I'll take one more example here, which will more related. So, let's take that somebody wants to take admission, okay, into into engineering. Okay, so if somebody wants to take admission into engineering, then in that case, what is going to happen in that particular case? Okay, so we have science as one subject. We have maths, and then we have let's say social science. So these are there. Now, I will give some in random way. I'll give some marks over here to these people. Okay, so let's say we have multiple records for multiple people. So I'll give some random marks to them. Hmm. Okay, so now these random marks could be, let me generate some random marks here, make it a little larger. So is equal to R&D ran between, let me, so some random marks I'm generating, and let's say somebody got minimum marks as 20 and maximum could be 100 out of 100 marks. So I'm putting some 10 records over here. These are the 10 records. Okay. So you can see that different marks we are able to see here. And I think we can have little less also, from 0 to 100. Okay. So when you are making a model, that how will you be giving admission to a student based upon these 3 marks. So first of all, we will discuss that we should give more weightage to science, little less weightage to like very less weightage to maths, social science, and a good weightage to maths. So we will consider weights over here. So the first weight W naught, okay, W naught we will give for, or I'll just write SCI science W, weight for science. So the weight for science I'll be giving is 0.5, 50% weight. Okay, I'll give, and it doesn't matter, like the weight should be 0 to 1. Okay, 0 to 1, it is that how much percentage of that particular science marks you want to take into consideration for making up a decision for a person whether he should take admission into engineering or not. Okay. Then secondly, for maths, so math maths w, so weight for maths, I'll give 0. I'll give 8 9. Okay, so very high weightage for mathematics. And then social science weight, I'll be giving just passing marks, like 0. Let's say just 30% or 40% of the passing marks. Even that is not required, but person should just pass. Okay, so I'll give 40%. So I believe this weights concept is now making some sense, that why do we have weights? Because it's weightage of that particular subject. But in real time, some sort of error or noise is there. Okay, like everything doesn't happen in a perfect manner, right? In very perfect manner, everything doesn't happen. So therefore, some error may be there. So that is known as bias. Okay, that is known as bias. So that bias could be anything. So I'm just making an assumption and making the bias as of now I'm just making it at 0.2. Okay, this is the bias. So what is happening here now is we have a concept of weights, that how much weightage a particular subject should get. We have something called as bias, and now we will try to fit this all into a formula. Okay, and let me make these static values. These are coming from formulas, so copy and paste, and I'm making them static. So only values. So here we just have values. Okay, now the formula I'll have is, first I'll write it manually. So y is equal to, y is will be ranging, will be giving some score, and that score will be helping us to decide whether we should give the admission to the student or not into engineering. Okay, we'll be giving that way. So here I'm writing y is equal to, we have bias as 0.2. So here I'll write BIAS bias, plus we have score of science. So science score into, we have science weight. Okay, similar way, plus we have math score, and then into math weight, and plus we have social science into social science weight. This is what is the formula. Okay, and now I hope it is understood that we are taking one error term which affect the output, because we know that in real life everything doesn't happen with the formula. Okay, so although we have speed is equal to distance upon time, but there are so many other factors in real life which does not make this formula very much real. Okay, so in ideal situation only speed is equal to distance upon time. Otherwise, speed is something different from distance upon time. I hope you agree on this part. So that basically is bias over here. That particular that irregularity which is happening, which is deviating from the formula, is because of bias term. So that is why we have taken bias. Weightage I have told you in this example. So each feature will have some weightage. Okay, every feature will not be equally important. Fine, so therefore we have taken weightage here. Now let's basically apply it. So is equal to, we have bias, so I'll select bias, and then after selecting bias we have plus, and then we have a value. So I'm doing for 2 second wala. Okay, this one. So I'll take this and into, then science weight, so this one. After that plus, now we have I'll take mathematics, and mathematics into, I will take maths from here. Then we'll take this into, and I think I'm done. Enter. So you can see that the output we are getting is 56.35. Okay, this we are getting for, let me copy this and let me put it over here. Some references got corrupted. Okay, so let me just do it once again. So here this is fixed, bias is going to be fixed. Okay, so because bias is going to be fixed, I can just write 0.2. Okay, bias is going to be fixed. Then okay, is equal to 0.2. Bias going to be fixed. Into I'll have to do write this one. Okay, this one into 0.5 is also going to be fixed. Okay, and there is this plus actually. So here and then plus. Then we have yeah, is it not done? We have this value into next one is 0.89. 0.89. Okay, then plus this value into 0.4. Okay, so here we have all the uh, scores computed. So you can see all the scores are computed, and we can gain something out of these scores. Now here if you see that highest the score, what value we are getting? We are getting higher value. Okay, so higher score we are getting higher value. And if you want to make up a decision, you can make up a decision by looking into the score. Those who are getting the highest score, you can give it to them. But there is a problem in this. Okay, there is a problem in this. The problem is that in this particular example, the weights are wrongly assigned because here, if I see, I would have given very low marks to this one. Okay, he has got 92 here, he has got 82 here, but maths he has got just 9. Okay, just 9 he has got. So I really would like to reduce what? I would really like to reduce this 0.4. Okay, why I would reduce this 0.4? Because 0.4 is very higher for social science, 40%. I would just like to give it, I can give it 0, 0 also, or I'll just give 0.01. Okay, very low I will give. So I'll just change the formula here. So let me just take it. Okay, this is, I'm putting it here just as a value I will paste. Okay, and now I'll change the formula here, and I'll give it 0.0101. So the least weightage is given to the third one. Now you can see there is a change, whole change in the outputs. Okay, whole change in the output. So the whole change, now you can see the maximum number we are getting. Okay, this one is getting 55. Here you can see this one is getting 55 only, and here this one is getting higher, 105. So this is how I actually would like to have that. Social science should have very less weightage, mathematics should have very high weightage, even science can have little less. I'll be okay with that. Okay, so those who are very strong in mathematics should go for engineering stream where mathematics is very high, at least for first 2 years. Okay, so this is how I'll be doing. So now I think this example must be making sense, that why I'm considering weight and why I'm considering some bias. Bias is basically natural error. Okay, that happens. That always happens. I gave you example of speed is equal to distance upon time. It happens there also. And let's say two students are studying for same number of hours. They're studying from same teacher, but still their marks are not same. Right. So why? Because of some natural bias. Some deviation would be there. It won't go with mathematical formulas. So is this example making sense about weights and bias? So this is what a neural network does. A neural network actually works on these two things, weights and bias. So here I am manually basically trying to explain you by taking some values. But what neural network does is, neural network looks into the weights and bias, and then neural network uh, keeps on updating them, not for one or two times, but in few lakhs times also. uh, and it depends, like if data is very huge and complex, then probably for more time it will. So with multiple iterations it actually works on weights and biases. So So we were working on this part. A neural network has layers. So this is the task of hidden layers actually. Okay, so hidden layers do this, and then we have activation functions. Okay, activation functions, they help us in order to give the outputs. Okay, they give us the output. So this happens, this weight is applied before the activation function, bias is applied before the activation function itself is there. Okay, where it is going to, I'll show you some of the activation functions. So it will yeah, it will take everything as input, so, and will give some output, and that thing is being given here. Okay, the product of each of the input value and the weight of the channel is passed over. Okay, is passed over is found. It computes the sum of the weighted products. We call this as weighted sum. So here what we did, this is called as weighted sum. Okay, when we were actually doing a2 into 0.5 plus b2 into, this is weighted sum. So then it adds the bias, a unique to the bias unique to the neuron, to the weighted sum. So bias is a single value as I have added over here. So this bias it adds. Okay. Then when we then subject the final sum to a particular function. Okay. So to a particular function, we basically we insert the final sum. Now look at diagrammatically the same thing. We have input x1, x2, x3. Then here we have summation xi wi. Okay, that means x1 plus x1 w1 plus x2 w2 plus x3 w3 summation. Okay, plus bias will give us the output. Okay, plus bias will give us the output. Yeah, so this is understood now. Now let us move ahead and try to understand more on a activation function. This is one of the simplest activation function you can see here. Okay, one of the simplest. We call it as sigmoid function. So if you see that the sigmoid function is 1 upon 1 plus e raised to minus x. This is sigmoid function. You can see that it ranges from 0 to 1. And let me help you again with sigmoid function here. Okay. So whatever values you have, whatever values, okay. So let's say here we have x. X is the input, therefore I'm taking it as x. And my x is, let's say, it ranges from a minus value, minus 100, and I will generate from minus 100 to um, minus 99 this way. So I will generate till positive. You can see that we have, yeah, so we have 100. So I have generated some values randomly. I have generated some values. Okay, from minus 100 to 100 I have generated. Okay, now I need y. Okay, y is coming from this sigmoid function. So sigmoid function is 1 upon 1 plus e raised to minus x, right? So what I will do is, let me first have uh, e raised to minus x. Okay, so is equal to exp exponential, okay, minus, and x is this value. Okay, this value. So exponential, so this is the value we are getting, and here I'll put the formula 1 divided by, in bracket we have 1 plus, so 1 plus this value. Okay, fine. So this is the y sigmoid function, right? sigmoid sigmoid function. So let me have this for all, and let me have this also for all. Now if you see, insert recommended chart, and I'm taking this chart. So now can you observe this chart, like what sort of values are we getting? Let me bring the chart on top. Yeah, so here you can see, sorry, yeah, this much is fine. So look at this particular chart now. Okay, so what are you able to see here? The values are ranging from 0 to 1. I have taken so many values, but the output for all the values is coming from 0 to 1 only, right? This is very much clearly visible over here. This is what we actually expect. Okay, this is what we expect from some of the data. Okay, so for example, here also in this particular case also, what we will be expecting is that 56 is the score. Okay, so whatever, like 42, 105. So I would like to transform this value. Okay, this value with the help of a sigmoid function. Why sigmoid function? Because if I transform this value with the help of sigmoid function, I'll be only getting values from 0 to 1. And what I will do is I'll try to create a threshold over here. Okay, and that threshold will tell me if the value is above threshold, it is coming under first class. If the category, if the value is below threshold, it is coming under zero class. So I have 0 and 1 as two classes. Okay, so one class, let's say the student can take admission, and zero class, that means student can not take admission. So this is how I can work upon. Okay, so the purpose of activation function is that it will help us to make decisions. Okay, so if the decision is binary, yes or no, true or false, then basically sigmoid function can be one of the most easiest one to help us with. So this one is sigmoid function. The sigmoid function is used for models where we have to predict the probability as an output. Okay, so although you can see the formula, I have shown you the formula, it is not probability, but it looks like probability. Okay, okay, coming back, yeah. So it looks like a probability, but it is not a probability. Okay, then we have another function which is called as threshold function. Okay, so threshold function, if you see what happens in a threshold function, now it is a threshold based activation function. It makes the function active and fired if the value of x is greater than a certain value. So sometimes this is also a case. Okay, so here you can see that it will have certain value. Based upon that certain value, it is going to happen. Okay, this is going to work. So x, the output is going to become 0 if x is less than 0. The output is going to become 1 if the x is greater than equal to 0. So here basically the threshold, we are taking it as 0. Okay, threshold can be some new value also. Okay, some it may be 5, 4, 3, 2, 1. Okay, some specific value can also be there. Okay, so a value a could be there. So if x is greater than a, then basically 1. If x is less than a, then it is 0. So that is also how threshold function works. Okay, now you can understand that we need to get some ways of getting the output. Okay, some ways of getting the output. So one way is use sigmoid function. Another way is threshold function. Another way is rectifier function. In this particular function, it takes max of x and 0. Okay, so max of x and 0. So if x is positive, then positive. If x is negative, then basically 0. Okay, so that is what is the function. So if x is positive, then that particular number x will be the output. If x is negative, then 0 would be the output. Okay, so it is most widely used activation function and gives an output x if x is positive, 0 otherwise. Okay, we have hyperbolic tangent function also. Okay, so this is similar to sigmoid, but the range changes. Here the range changes from -1 to 1. Okay, so similar to sigmoid, but range changes. So I hope you are getting that. These are some functions which are actually going to help us to bring the final output. Okay, in between they will help us to like develop the model in the hidden layers, but ultimately one of these functions will be used for making the final output. And for that, normally we have been using the sigmoid function, and there is a function called as softmax. So that is one which we use mostly in the output stage. Then there is this concept called as cost function. Okay, there is a concept which is called as cost function, and this cost function basically means that let's say I am computing score of a particular person, and I computed the score and the score came as let's say 20, and then we actually found that the actual score is not 20, the actual score is 25. So cost function basically tells that if I'm telling that somebody has got marks, let's say 25, and actually he has got marks as 30. So what is the difference between the marks which I'm telling and the actual marks? So 5 is the difference. 25 and 30, it has got 5 as a difference. So this is basically called as what? This is called as cost of basically taking the output. So the cost function returns the difference between the neural network's predicted output and the actual output from a set of labeled training data. Okay, so it becomes supervised here. The least cost value can be obtained by making adjustment to the weights and biases iteratively throughout the training process. This is what I was explaining here also, that in this particular case, in the sheet 2, let's go. So here we have science, maths, social science, and we don't have the output. Okay, whether that person got selected or not. Let's say we have got some output also. I'll just take here. So y is the output. Okay, and we have y pred is the predicted output. So here we have, let's say, 2, 4, 5, 3. So now let's say the prediction is, here the prediction is 1.8, here the prediction is 4.1, here the prediction is 5, here the prediction is 2.6. Okay, this way the predictions are there. If this way the predictions are there, in that particular case, what's now if you see that, what is the difference? Okay, difference between y and y spread. What is the difference? Difference is, I'll find absolute difference, ABS, absolute difference, this minus this. So I'm finding absolute difference. So you can see this is absolute difference. This is the difference. And let me do the summation. This is basically your difference in y and y pred. So that difference will be called as cost or error. In simple terms, you can call it as error actually. So cost function returns the difference between the neural network's predicted output and the actual output from a set of labeled data. So the way I have done is, this is a simple cost function, finding y minus y pred and summing it up. Okay, so the least cost value can be obtained by making adjustments to the weights and biases iteratively through the training process. So if I want to make improvements, what I'll have to do? I'll have to change weights and biases so that the predicted output gets updated. Again, I'll find the difference. Again, see what changes is it making. So 2-3 times we can do that thing. Okay. So I hope you're getting this part. So cost function is the error function, computes the error. If you minimize the cost, if you minimize the error, you have to do what? You have to iterate and update the weights and biases. That is something you have to do. All right. And here diagrammatically you can see how cost function looks like. We have input, we have the neuron, it gives the output, but the predicted output and actual output has got some difference. So therefore we back propagate, we go back, we make some changes, and then we again compute. And we do this till the time we get the desired cost reduced. Okay, so that is how we do.